Oh, hi. Check out this box on top of here. And then the whiskers from the tiger. Put them together, you got a box and whisker. Sometimes they call it box plots only. Now, today you will organize data, and from this box and whisker, you can compare different sets of data. Are we ready? Here we go. All right, so let's have a quick review. In the past, we learned about the measures of center, okay? A number that represents a set of data. We could use mean, median, and mode. And then we also talked about variation, how spread out are the data. We could use the range or the mean absolute deviation, MAD, right? Now, today we will represent the data. Data could be represented as a dot plot. Remember the dot plot? Each of those dots represent the data. And today, again, because we're very visual, okay, this is now called the box and the whisker plot. Okay, so now we're ready. All right, ready for example number one. Let's read the problem. The problem reads as, how much money do you have now? That was the question. And then 7 students responded, oh, 32, I have 20, I have 5, I have 10, I have 17, I have 18, I have $16. So these are random numbers. We'll have to organize them. And the first step is to order them from least to greatest. All right, simply ordering them from least to greatest. Let's just copy the numbers. The lowest number is $5, followed by $10, followed by 16, followed by 17, followed by 18, followed by 20, and the biggest number is 32. All right, so once you know that, you will need 5 data points. What is a data point? Those are the 5 information that you need to make a box and whisker. The upper extreme, the lower extreme, the median, the upper quartile, and the lower quartile. All right, so let's start with the upper extreme. The upper extreme is the, let's read it. The upper extreme is the maximum or the highest data, the highest number. Okay, let's select the highest number. Obviously, it's what? 32. Yes, 32. Okay, next. The lower extreme is the lowest, the minimum, or the lowest data. What is the lowest number? Say it. Correct. It's a 5. All right. Now, the median. Remember, we have a process in getting the median before. Let's cancel the middle number. Yes, let's cancel from each side. Cancel this, cancel that, cancel that, cancel. Left, right. Middle number is 17. So I write down the number, median number 17. Are we good so far? All right. Now, the upper quartile is upper numbers go over here, right? The upper. Now, check this out. So 17 divides the numbers. It divides the numbers. So these are the numbers on the upper. These are the numbers on the lower. Remember, this is the upper. This is the lower. Okay, now the lower quartile is this. You will have to do something like a median, a mini median. So let's do the cancellation. Check this out. I want to get the middle number from the upper. Okay, look. Cancel 1, middle number 20. See that? So I will have to write 20 for the upper quartile. Okay, now go to the lower. The lower is on the left side. Let's look at the left side. Let's now cancel the numbers again. So let me cancel 1 on the left, 1 on the right. The middle number is 10. And it's in the lower. So it's called lower quartile. So let's write down 10. Now, these are the 5 points that you will need to make the box and whisker. Let's just do this. The next one is the interquartile range. We don't need it yet, but you will use it later. It's simply Q3 minus Q1, or the upper quartile minus the lower quartile. And that's going to be what? It's going to be 20 minus 10. The answer is 10. Okay, we'll use that later. But we'll use first the data from above. Okay, let's start with the upper extreme. Check this out. The upper extreme The upper extreme is 32. Where is 32? 35, 30 and 35. 32 is somewhere there. Put a dot. The dot should be floating. Okay? That's the upper extreme. Check. The lower extreme, 5. Check. 5 would be here. Put a dot. Okay, we have 2 dots already. That's going to be the extreme values. Okay, now let's do the median. The median number is 17. Where would 17 be? 15 and 20. 17 would be somewhere here. I put another dot. Okay, check. The upper quartile is 20. Where would 20 be? 20 would be here. Put a dot. And then the lower quartile is over here, 10. Put a dot. Okay, guess what? This is what you're going to do. You're going to connect and make a box from your lower quartile. The box will continue up to the upper quartile. That's the box. And then between that, there's a median. So that's the box. All you need now is the whisker. So connect the lower quartile to the lower extreme, connect the upper quartile to the upper extreme. That's now a box and whisker plot. And what does that mean? Okay, this is again, the median. This is quartile 1 or the lower. This is called quartile 3 or the upper quartile. Yes, this is the lower extreme or the minimum. Lower extreme, this is the upper extreme. Okay, now what does this mean? This means that each portion, you could see that the data was spread out into 4. Each portion represents 25% of your data. Okay, so the 50% is the box. Okay, from the box to the whisker is another 25%. That's why it's called quartile, cuatro, right? So that's it. So that middle part tells you that 50% of my data is from 10 to 20. Okay, half of my data is between 10 to 20. All right, we got it? Now, suppose I got the results of your test last week, and then I made a box and whisker out of it. This is the box and whisker. And you're curious, what are the data? What does it represent? Okay, let's look at it now. So I want to know 5 important data. Let's start with the upper extreme. The upper is the highest number. Based on that, remember, that's the end of this. Between a 95 and 100, what could this be? Let's say, what do you think? Yes, 98 would be fine. Let's write down 98. Next would be the lower extreme. Which is the lower extreme? Going down and to the end, that's going to be here. It's not a 70. Let's say that's a 69. All right, so let's say that's a 69. Okay, next, the median number. The median number is the middle number of the box. The middle number of the box is here, 85, 85. So that's the middle score of all my students, 85, who took the test. And next, the upper quartile. The upper quartile will be on the upper half. It's on the right side of the box. The right side of the box, this. What could that be? 95, between 90 and 95. Let's say that is 90. 94 would be fine. 94. Okay, next, the lower quartile. The lower quartile would be, or sometimes they call it quartile 1, would be between the median and the lower extreme, or the left side of the box, 75, and before you reach 80, let's think of it. It is a what? 70? Yes, 79 would be fine. All right. So now these are the 5 important values. Now, if you're asked for the interquartile range, right, to know the middle part, how big is the middle part, how expanded it is, or the variability of it, so simply subtract these two. So 94 minus 79, that's 14 minus 9 is a 5, 15. So IQR is 15. Okay, let's just interpret the data. So the middle number of my class is 85. This kid got a 69. He failed. And then this kid got a what? got a 98. The highest score on the test is a 98. And 50% of my class would fall between these grades. 50% would be from 79, because that's 79, to 90, what is this? 94. All right. So that's how you interpret your data using a box and whisker. All right, let's pause the video and try this on your own. Okay, now let's try. I'll show you how it's done. Okay, least to greatest, 32, followed by 44. There are two 44s, 44, 44. What else? I got a 48, 48. I got a 51, 51, then a 59, 59, then a 60, 64 first, 64, followed by a 65, and then a 96. All right, put them in order. That's number one. Put them in order. Next, I need my upper. The upper is 96. The lower is 32. Okay. The median, how will I know the median? Get the middle number. Cancel, 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 cancel. There you go, 51. All right. Upper quartile, look at the upper part, the middle of this. Cancel, 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 cancel. Oh my God, there are two middle numbers. So 64 plus 65 is 129 divided by 2 is 64.5. So 64.5. Now, from the lower quartile, cancel, cancel. There are two middle numbers. What's between 44 and 44? It's a 44. So 44.0. And then the IQR, simply subtract this. Okay, subtract 0.5. Yeah, 0.5, and that's going to be 20. All right, so now I know these five values. I can plot these five values. Did you do it? Okay, let's check. The upper, oh, I don't have numbers here, but my number starts from what? 30 to 100. So let's start from 30, 40, 50, 60, 70. You make the scale, right? It's not always there. 80, 90, and 100. Okay. The highest is 96. Put a dot. The lowest is 32. Put a dot. The median is 51. Put a dot. The upper quartile is 64.5. Put a dot. The lower quartile is 44. Somewhere here. Put a dot. Again, the middle one will be the box. Okay, there's a line inside the box. That's the median. And the whisker will extend over there. All right. Box and whisker. What can you say? The middle numbers, 50% of the data are this one. Okay, that's 50% of your data. Okay, we good? Sometimes you will see two dot plots, one on top of each other. What does that mean? It wants you to compare them. All right, so let's look at this. The box plot shows the weight in pounds of the dogs in two different animal shelters. This is shelter A and this is shelter B. So let's see. Which describes the spread of the data in the two box plots. Let's start from the bottom. The data in shelter A ranges from 21 to 28. A begins from 21 to 28. No, it begins from here to there. So that already is wrong. Okay. Next, the data in shelter A ranges from 17 to 28. 17 is over here, 28 is over there. No, that's only 50% of the data. It ranges from this to that. So you're wrong. That can't be the answer. Let's look at the third one. The data in shelter B shows more spread than data A. Is that more spread? Is this longer than that? Even the 50%, this is shorter than that one. So definitely it is not spread out. So maybe the number one is correct. The data in shelter A shows more spread than the data in shelter B. Why? Because look, it's longer than this one. Even the 50% is longer than the other 50%. So this is our answer. Check. Next, let's read the second problem. The box plot shows the number of hours that Mr. Young's biology class spent studying for a test. It also shows the number of hours Mrs. Gonzalez spent studying for a geography test. So, for Jan's biology and Gonzalez geology, two different classes, and these are the results. Four students compare the data in the box plot. Let's see which of the following makes sense. Okay, let's start with Nadine. The medians are the same. Let's see, are the medians the same? No, they're not. Mr. Yan's class has a greater median because the box plot is larger. Mr. Yan's median is not greater. It's actually less. And it is not based on the, look at this. This is less than that. And it's not based on the box. It's based on this number. So definitely you're not right. Now, let's look at Tahara. Mrs. Gonzalez's class has a greater median because the line inside the box is located at a greater value. Okay, the line inside the box, which is almost 6, maybe 5.8 or 5.9, but you're just a 4. This makes sense. This makes sense. Let's look at the last one. The medians are both 7. Are they both 7? No, that median number are different. They're not both 7. Okay, so the correct answer is Tahara. Got it? Okay, let's read this. The box plot shows the average speed in miles per hour for the cars in two different races. This is average speeds of race A, average speed of race B. Let's read if this one makes sense. We're looking of half. When you say half, you only need the 50%. Okay? So, between 120 and 143 of race A. Race A is here. 150, 120 is over here. And 143 is over there. Does that represent 50%? No, forget it. Between 120 and 170. 120 and 170. Okay, is that 50%? Yes, this makes sense. But let's look at the second part. Between 125 and 165. Okay, between 125 here and 165. Ooh, that's 100%. Okay, so this is definitely wrong. Okay, now let's see. Let's use another one. Between 120 to 153, 120 to 153 over here. Look at the blue one. Is that 50%? Yes. Okay. How about the other one? 125 for B now. 125 starts here to 145. 145. See that? This part and that part, 25 and 25, that represents 50%. Okay, so this makes sense. Check, check. How about the last one? Let's look at the last one. Between 165 to 170, 165 to 170, that's only 25%. Okay, so that's definitely wrong. I don't need to check the other one. So our correct answer is this one. Okay, that is correct. Okay, last problem. Let's read this. The box plot shows the weight in pounds of animals in two different zoos. In the city zoo and in the country zoo. All right, these are the animals and these are the weights. Okay, what is the difference between the median weights in the city and in the country? Oh, median. Where do I find the median? That's so easy. The median is the middle number inside the box. Okay, for you it's 140. For you it's 150. Okay, So it says the difference. What do you mean by difference? You'll have to subtract. Okay, so country has 150 and city has 140. Subtract them, and you get what? 10. 150 minus 140 is 10. So this is the answer. All right, got it? So guys, remember, results is equal to action plus motivation. Good luck.